This video will cover the topic using a calculator to approximate cosecant, secant, and cotangent values. In this problem, we will be using the ALEKS calculator to approximate the trigonometric ratios of cosecant, secant, and cotangent. CSC stands for cosecant, SEC stands for secant, and COT stands for cotangent. It is also important to note that the cosecant is defined as 1 over the sine of theta, secant is defined as 1 over the cosine of theta, and cotangent is defined as 1 over the tangent of theta. Here we are asked to find the cotangent of 13 pi over 8 radians, the secant of negative 90 degrees, and the cosecant of negative 240 degrees. And we are asked to round each of these answers to the nearest hundredth, or in other words, the second decimal place. Let's begin by solving for the cotangent of 13 pi over 8 radians. Since we are working with radians, we must make sure that our calculator is in radian mode. Cotangent is defined as 1 over tangent of theta, so we begin by entering 1 over tangent. In this case, we are finding the cotangent of 13 pi over 8 radians, so we enter in 13 pi over 8. Finally, we click on the equal sign to find our answer. The result is negative 0.4142 and so on. Rounding to the nearest hundredth, the result is negative 0.41. Next, let's calculate the secant of negative 90 degrees. We are working in degrees now, so we must change our calculator back into degree mode. Secant is defined as 1 over the cosine of theta, so we enter in 1 over cosine. Here we are asked to find the secant of negative 90 degrees, so we enter in negative 90. We find the result is undefined. This is because the cosine of negative 90 degrees is 0, and 1 over 0 is undefined. Finally, we are asked to find the cosecant of negative 240 degrees. Cosecant is defined as 1 over sine of theta, so we enter in 1 over sine. We are asked to find the cosecant of negative 240 degrees, so we enter in negative 240. The result is 1.1547, which rounded to the nearest hundredth is 1.15. Our final step now is to check our answer. We check our answer, and we find that our answer is correct.